In this video, I'm going to be talking about this thing called the discriminant. And the discriminant comes from the quadratic formula. So if we have the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. There's our quadratic formula. The discriminant is really just this part right here. So take that value, that b squared minus 4ac, and that is the discriminant. So we don't use the square root. It's just b squared minus 4ac. The answer you get from this is called the discriminant. And it helps us for a couple of different ways. It gives us some clues about solutions of quadratic equations. So if we solve any quadratic using our quadratic formula or any other method we use to solve a quadratic equation, the discriminant will tell us the type of solutions. So is it a real number or an imaginary number? And it also tells us the number of solutions. So do we get two real solutions, two real number solutions, or do we get two imaginary solutions, or do we just get one? So really, the solution or the answer to this equation right here tells you a few things. If the discriminant is greater than 0, so if it's positive, then we have two real solutions. If the discriminant is 0, if this whole equation equals 0, then we have one real solution. And if the discriminant is less than 0, meaning if it's negative, then we get two imaginary solutions. So it's kind of nice. I mean, it's not super important, but it does give us another way to check that we're doing or solving a quadratic the correct way and that we got the correct solutions. So let's try out a couple of things, a couple examples here using the discriminant. Let's try x squared plus 6x plus 9. So if you recognize this as a perfect square, we could factor it and solve it. And we might do that in just a second here. But let's plug this in and figure out what the discriminant is, and then check that with our solution. So b squared, b is 6, so what's 6 squared? Minus 4 times a is 1, and c is 9. So what do we get when we do this? We get 6 squared is 36, 4 times 1 is 4, times 9 is 36, so we're minusing or subtracting 36. Well, our discriminant is 0. What did we say? If the discriminant is 0, then we get one real solution. So our solution that we get when we solve this should be a real number, and we should only get one solution. X should only be one real number. Well, let's see. Again, we could do this using the quadratic equation. I'm going to show you real quick. If you've already solved the discriminant, that's usually the thing that takes the longest when using the quadratic formula. So out front we had the opposite of b, so negative 6 plus or minus, and what's underneath that square root is what we already solved. We found that the discriminant, the b squared minus 4ac, equals 0. So really we can just put the 0 there. And then we're multiplying the bottom, 2 times a, which is 1. Square root of 0 is 0, so really what we're doing is negative 6 plus 0, well that's still negative 6, divided by 2. So we get negative 3. And then we got negative 6 minus 0, well that's still negative 6, divided by 2, which is still negative 3. So there is only one solution, and it is a real number, so we get one real solution. Now, like I said earlier, this was a perfect square. We could factor it fairly quickly and get the solution just as well. Square root of the first term, square root of the last term with the middle signs, and squared. So if we set that equal to 0, we get x is negative 3. So it doesn't matter how we solve it, but we knew we needed to get one real solution, and we got it. So chances are we're correct. Let's try another one here. Let's do 2x squared plus 4x plus 7. Right off the bat, if I wanted to factor this and solve it, I would have to use xbox because a is greater than 1. But then I would have to do factors of a times c, so factors of 2 times 7, so factors of 14 that add up to 4. I'm not sure that there are any. Let's see, 7 and 2, 14 and 1. That's about it, right? None of these add up to 4. So this appears to be a prime quadratic. So let's see what values we should get. Let's use our discriminant. B squared minus 4ac. So 4 squared minus 4 times 2 times 7. That's 16. That's 8 times 7. So 16 minus 56. That gives us a negative 40. Well, our discriminant is negative. If the discriminant is less than 0 or negative, then we get 2 imaginary solutions. Well, let's see if that's true. I'm going to go ahead and use the quadratic formula since we already solved the discriminant. So inside our radical is negative 40. Outside we got the opposite of b, so negative 4 plus or minus that. All over 2 times a, so 2 times 2. Let's simplify the radical here. That's I. We take the I out for the negative. So really we're doing the square root of positive 40 with I on the outside. Plus or minus. Let's just rewrite everything. All over 4, right? 2 times 2 is 4 on the bottom. Let's factor under the radical still. So simplify under the radical. That's 4 times 10. Okay, so 4 times 10 under a radical means we take the square root of 4 out. So 2 goes on the outside. So now we have 2i on the outside. We still have the square root of 10 because we can't simplify that anymore. Still have negative 4 plus or minus that, all being divided by 4. Well, now our last step here is just to rewrite this as 2 different fractions and simplify them. Negative 4 over 4, this is what I'm doing first, this first fraction. Negative 4 over 4 gives us negative 1, right? And then we got 2i times the square root of 10 all over 4. Well, this reduces to 1/2. Plus or minus 1i over 2, and we still got the square root of 10 there. Basically all we have to do is just rewrite it nicely, something similar to standard form here. Negative 1 plus or minus square root of 10 over 2 with the I on the outside. So we did get 2 imaginary numbers. We got negative 1 plus the square root of 10 divided by 2 times I. That's one imaginary number. We also have negative 1 minus the square root of 10 divided by 2 times I. So there's our 2 imaginary solutions right there. Let's try one more here. 3x squared plus 9x plus 5. Let's do the discriminant, find out what type of solutions and the number of solutions we're looking for here. B squared minus 4ac. It's 9 squared minus 4 times 3 times 5. That's 15 times 4, 15 times negative 4 really. So that's negative 60. 9 squared is 81. 81 minus 60 turns out to be 21, right? Well, that's a positive number. So if the discriminant is greater than 0, meaning if it's positive, then we get 2 real solutions. Let's see if that's true. Again, since we solved the hardest part of our quadratic formula, might as well just use that to solve it. So 21 goes under the radical. Opposite of b plus or minus, and 2 times a on the bottom. The square root of 21, that's as simplified as it gets. You only get a decimal from that. So we got negative 9 plus or minus the square root of 21 over 6. So let's break that up into the 2 fractions and simplify. Negative 9 over 6 plus or minus the square root of 21 over 6. Well, negative 9 over 6 is negative, 3 halves? Plus or minus square root of 21 over 6. Can't simplify that one anymore. So there's our two real numbers. I mean, we could get decimal values and really look at how real they really are, but we're not using any imaginary numbers, so they must be real numbers. And we get two of them. We got negative 3 halves plus the square root of 21 over 6, and we also have negative 3 halves minus the square root of 21 over 6. So there's our two real solutions. And that is basically the discriminant. It gives us the information about the solutions. And it also gives us a jump start or a head start on solving, because we've already solved underneath the radical. And all you got to do is plug it back in and solve. Alright, so good luck using the discriminant as a way to kind of check your solutions.